Welcome to the University of Arizona's Center for Applied NanoBioscience and Medicine at the College of Medicine in Phoenix. I am Professor Frederic Zenhauser, Director of the Center, and here at the institution we really develop technology for the future of precision health. My first invention experience go back to my time at IBM Research, and typically when I joined the company as a postdoc, and I joined the company when Lou Gershner came on board and completely transformed IBM and really revamp the overall operation. And as part of that, the overall invention process within the company got changed, re-engineered, and that's the time when the company really realized that they could value and capitalize really the business through invention. And that's really at the time where also I got very privileged to work in an amazing environment where the culture was really directed toward invention. And we really work to develop portfolio about ideas that we were really thinking for the future. So we are not afraid of thinking and developing a pattern, forward pattern, really thinking about what will be the next generation of ideas. So that's really my first exposure to invention, and really learn how the training also was very important, and that's really when the company developed a training program for young scientists as well. Yeah, the center has been very productive in terms of new technology platform development, and always looking at building also the IP and patent portfolio supporting those ideas. And in that context, we have a lot of different programs with government agencies, but also corporations. And one example has been through a large program with Boeing Corporation to develop new fuel cell system for the commercial aircraft. And during that project, we developed a new materials to support the catalyst for the fuel cell, cathode materials. And in that context, we came also with a new idea to apply maybe that materials for consumer product and use that for building a surfboard. So it's really something out of the box for us, but we came with that idea, and we tried to pursue it in the context of the time in 2005, when the largest supplier in the world of blank foam for the fabrication of surfboard decided to shut down the company because of a very stringent standard with the EPA due to the pollution of the process for fabricating those blanks. So our materials was really coming here as a new materials and hybrid nanomaterials for which we can fine-tune the mechanical properties and have unique properties that the surfer really wanted, but also the materials was really a green materials. So we decided to connect with UCSD program in terms of technology transfer through Connect. That's a small venture program they have in California. And through that exercise of developing a business plan, we didn't do the surfboard, but we came out with another application that ultimately resulted in the foundation of a new startup company, Diomix Corporation, which is now based in San Diego, California, developing a new materials to collect DNA at the crime scene. And that materials has a unique properties to be soluble, so you can release a lot more of the materials that you collected at the scene. So really those kind of products can evolve from, again, multiple application and fuel cell and life sciences and others, and ultimately get transferred into the commercial world through a corporation and licensing back, of course, to the university. And similarly, in the same context of DNA forensic, we develop a small rapid DNA machine through a large program with the UK Forensic Science Service in England. And similarly, we build a large portfolio of patents and ultimately transfer those technology again in a small startup company, as well as getting that technology ultimately validated through multiple programs on police forces across the world. The center has a very large IP portfolio, and we use that very actively to support our research portfolio and getting our research program funded by a different sponsor. And having the portfolio positioning is very important. So we had a large European program with the 7 framework and a consortium on security with several police forces in Europe, in Germany, Austria, the Netherlands and the UK, for which our portfolio was critical in the establishment of that consortium, and the European community in Brussels recognized that importance of our portfolio and brought us as a US-based institution full right, like a full member in the consortium. So that's one example of what can be done having a very large portfolio that we value every day in our research. And similarly, we have a large program with the Department of Human and Health Services, with BARDA unit, the Biological Advanced Research and Development Authority, for developing a biodosimetry test that ultimately will be validated by the US government and potentially stockpile. And again, having the IP portfolio is very important for securing that commercialization and that development. So typically in industry, the process for the invention is a very broad spectrum or bandwidth in terms of the time where we create an idea until we potentially have even a contract with a partner or customer. So there is really that process integrated really through that development of the portfolio. In academia, we don't have that. It's a much more fragmented process where typically the IP will be filed very early stage, focus on the idea and hoping that we can either license the technology to a commercial partner and get royalties, or set up maybe a startup company and raise capital to build a business. So the approach is very different. It's really a different culture between those two worlds. As a producer of invention, serial invention within the institution and assisting the University of Arizona in promoting invention, one of my role has been also to promote and train students and young faculty about the process for the invention. So we try several programs. One, we do Helios summer internship program, during which we have a session discussing about invention, intellectual property law, and we bring some speakers as well to really make the student aware of that process as part of their training and as part of the responsibility of a scientist. A second program we have is also for young faculty. We develop a program called Health Expedition Research Opportunity, or HERO, and it's really a meeting, a monthly meeting during which faculty exchange ideas, and one of the requirements is to provide all the participants with a napkin and a marker, and that's really the concept here of summarizing some of those discussions and those ideas and concepts into the simple napkin concept. And we already collected several ideas out of those sessions that resulted either in pilot projects between faculty, but also in several invention disclosures. So invention at the university is very important, and that's really the future of innovation in our country and in academia for the next century.